Greetings, students. Welcome to CIVE 271, Fluid Mechanics. My name is Holly Monahan. I'll be your instructor for the lectures this term. Steve Cowden will be doing your labs. This video is just a welcome video, so we'll go through the course outline and how this course is proposed to be delivered for your fall semester 2020. Everything will be on D2L, both the labs and the lectures. Okay. This will include, course materials such as handouts. They'll probably be in PDF or PowerPoint or Word. All the assignments. The plan is for the lecture portion is that you'll have a 1-hour video of the lecture available by Monday at 10:30. So you guys can go through it, and then on the Wednesday at 10:30 we'll do a live study group. It'll be just running through some examples, calculation examples, and we'll do that live together. Okay. So I'm just going to go through this course outline. It is available on D2L. There's two little spots. There's a general folder, as well as I think it's in it's probably like course description. It's in there too. So you'll have this available for reviewing later on. But we'll just go through it real quick right now. So, like I said, my name's Holly Monahan. I am, for those of you who don't know, a professional engineer. I took this exact same program that you guys are doing now. Graduated 2003 from the tech program. Then I went and did the UBC transfer, the bridge program, and then did 2 years at UBC. And I've been working in coastal and marine engineering ever since then. So ports and harbors stuff. I've done a lot of like wind and wave analysis, so fluid mechanics is sort of my jam, as well as a lot of like marine structural stuff too. So I'll probably interject a couple of notes from my working life, their working life, into this course as well. So you'll have to excuse my digressions here. So there's a couple of different ways to get a hold of Steve or I. We've got our phone numbers there, as well as, hold on a second. There we go. Also our emails. If you're linked into the D2L, our emails are accessible there as well, but you can get us there. For myself, I can't speak for Steve, but for myself, text me first. This is just a cell phone. Text me first, and then I'll look into the email. I'm a lot quicker at looking at text, but I do, just so that you know, like I do run my own business as well. So I mean, I might not answer right away, but I will answer. Okay. So it's a big class. There's a lot of people in this course, so this will be fun. Hours, so we've got lectures and labs, and like I said, I'll be handling the lecture portion of it. It says a direct instruction. Like I said, you'll have like a video once a week of a lecture, and then we'll have like a study group. I'll record them and put them online too, just so you can see how we're just solving some problems, some example problems. The lab, I'll let Steve talk to you a little bit more about the labs. Needless to say, you need to learn the subject before the lab is presented, so it'll coincide with each other. So, little short description about what we're doing. We're going to be introduced to the fundamental properties of fluids, including fluid statics, so when the fluid's not in motion, laminar and turbulent flow, buoyancy and stability, fluid flow friction problems. There's also some advanced topics, so we're going to talk about series and parallel pipe networks, open channel flow, lift and drag, and why are you doing this? It's so that you can mainly do like water and sewer design and other hydraulic calculations. Like I said, there's quite a few of these things I do in my other working life too. So don't worry if this doesn't make sense now. It will. You know, you'll learn it all. So intended learning outcomes for this course: apply relevant safety regulations and best practices in the lab and in the field. So unfortunately, you guys can't, because of the COVID situation, you can't go into the labs right now, but Steve will be presenting all that stuff for you in his videos and all his handouts. It's gonna be good. So you're going to be able to calculate fluid pressures and forces for static fluids and fluids in motion. So like, what is a static fluid? You know, water in a pool, fluid in motion, water in a river. Just an example. You're going to assess a floating object's metacentric height and determine its stability. I do this quite often, believe it or not. Floats, houseboats, that kind of thing. You'll apply the general energy equation for flow in a closed conduit for series and parallel flow, considering pipe friction and minor losses. You'll also be applying the Hardy-Cross method for flows, losses, pressures in pipe networks. So again, if it doesn't make sense now, it will. You're going to be able to select pipes or pumps appropriate for different pipe configurations and flow requirements. You'll be able to select appropriate flow measurement devices, analyze uniform steady flow conditions for open channels, and determine specific energy for supercritical, subcritical, and critical flow regimes. So again, it might not make sense now, but it has a lot to do with open channel flow. Like a river is just an open channel flow, or a river, or you know, a little creek, those kind of things. And we'll go through it, why it's important later on. We're going to discuss pipe materials and standards for the purpose of selecting pipes and design. So you probably know under the ground there is different pipes carrying different fluids, such as water, sewer. One of my first jobs was working for the city of Burnaby, and they had a lot of jet fuel lines underneath their roads. So each different pipe material is specific for different applications, and we'll go through that throughout the course. And identify various types of turbines and their suitability for electricity generation. Oh, that's good. Got a little bit of experience doing that. So we've got the course content and schedule. So we've got a schedule we're going to try to adhere to. Like I said, Mondays 10:30 to 11:30. 10:30 will be your lecture videos will be up by then, if not sooner. You'll get an email from me saying when they're up. And that'll be just like the lecture portion. And then on Wednesdays, we'll have like a live study group. We'll just go through, in each of the lectures, there is some example problems that are presented. So in the lecture, you'll be given the example problem. You are encouraged to try them on your own before the Wednesday live class, where we just run through the examples. Okay. I'll be recording those videos too, and trying to upload them so that you have access to them. I know some of you are probably working still and doing that during this lovely time as before, when you just be in school full time. So the labs, I'll let Steve talk a little bit more about the labs and the videos and how they're going to be presented, but we do have a schedule here. This is your first week, so I'm just going to do a couple of lecture videos. There's actually 2, and I'll be posting those up separately after this, just a little course introduction. Okay, so what do we have here? So how you're going to be assessed your grading. The assignments are worth 15%. The labs are worth 20%. You're going to have 2 midterms. This helps to space out some of the marks so that it's not so heavily weighted. There's so each midterm's worth 15%. There's a final exam that's 30%, and then there's this other 5% instructor assessment. Okay. Textbooks. So there's text is Applied Fluid Mechanics 7th edition Mott. Same book I had when I was taking this course. Don't ask me what edition it is. I have no idea. So I understand that there is some physical copies of this available in the bookstore at Camosun Interurban Campus if you need them. Otherwise, you can get a copy on Amazon, or there is like a digital copy too if you guys don't have it. If you need to get an older copy, that's fine too. It's just the references might be a little bit off, like we might be talking about chapter 7 and it's chapter 5 in your earlier edition. It's not too much of a problem, but if you have any questions about the book, let me know. College support services and policies. So I got a little empty square there. I'll update this outline and put it up there. So there's immediate, urgent, emergency support there, different college services, college policies. So your second year attending, so I assume you guys know most of this stuff already. Grading system, it's just a standard grading system you guys are familiar with. Policies. So all the assignments and labs have to be completed before can write the final exam. If they're handed in late, there's a 10% deduction. If I've marked them and handed them back and they're already, the solution's already posted, if you hand in something, it's going to be graded as 0. It says here, assignments and labs are due at the start of the applicable lecture or lab. We'll still try to adhere to that. If not, you'll know. I've been emailing the class, as well as I put a lot of stuff in the news on D2L too, so it'll be on there when things are due, at what time, blah blah blah. If you have any questions though, let me know, because if something's ambiguous, you're probably not the only person who has a question. Okay. So you must pass the final in order to pass the course too. In addition, the weighted average of 50% on the midterms and the final exam must be achieved in order to pass the course, and you have to have a minimum 60% C to pass. Okay. Nothing that you guys aren't used to. So I'm looking forward to this course. I'll be posting 2 lectures after this. So one will be on the basics of fluids, fluid pressure, different nomenclature that we use, and then viscosity as well. I know you guys don't necessarily have a class for because it's supposed to be on the Monday, but I'll post them because you guys have some time. You have all of Tuesday, and then on Wednesday we'll be doing all the questions from them. Okay. Good luck, and I look forward to getting to know everybody.